Well, hello from Aurelia and my shop this morning for another shot at this radio. I want to thank those of you who are sending me emails. A few of you are sending me emails with ideas. None of them are hitting the bullseye yet. But thank you very much for taking the time to do that. What I hope to do today, start off with anyway, study the schematic here very carefully. I think I understand how these switches are working, what they're doing, and how they're doing, to some degree anyway. I can explain some stuff about that. I'm trying to explain this to myself, frankly, and you're listening to me talk my way through this is really what's going on. I think we get a better understanding of what these switches are doing, how they're doing it to the radio. We can then operate the switch while the radio's playing. We can then consider each position and the effect on the radio, and looking at the schematic and understanding what's going on. It might turn on a light bulb in my head, and we might hit on what the problem could be, and then we can go investigate that particular problem. That's the idea. You can see I've done a little coloring. I did that quite a while ago, trying to assess this light, but really it's only this morning that I finally understood in simple terms what this switch is doing to the radio. So let's take a closer look at it. We're going to concentrate on this for a while before we do any actual looking at the radio. I'll just bring the camera back over here. Now, I'm going to do this on camera rather than on a computer screen. I think it's actually easier. Okay, that looks fairly focused to me. Let's start here as soon as I get a nice pointer. Here we go. So the switch in question has 4 wafers. 1, 2, 3, 4 wafers. A lot of them have a lot of connections, but one of them doesn't. This one doesn't have many connections. But we're going to start analyzing this one. First of all, the way these switches are depicted. This one has no center ring. These 3 have a center ring. This one has a sliding ring here. This one has a sliding ring there. All these switches are shown from the front. It says and rotation clockwise, which is kind of a weird way of putting it. Clockwise, clockwise, clockwise. Now, one of these knobs, this knob, this is the knob. You can see the word off there. That sits on the shaft of this switch. When the radio is switched off, the off, it's going to be a little hard to show you. That's the off is going to be there. That's the position of the switch right now, off. So the actual contact positions don't matter as it's shown on the diagram here. When you operate the switch, you rotate things counterclockwise. Click. That's clockwise. Counterclockwise. How can you do that? How can it be off? No, it's set in the clockwise position to begin with. It's not necessarily off. Oh, I'm all confused here. Okay, I'm going to put the knob on the radio. This is why I'm doing this on here, on the video. Oh, son of a gun. Because I want to get this correct. I think the key to solving all this is understanding the switch properly and gaining insight on what effects occur when you turn the switch. Just a sec here. Put the right knob on. Has a flat spot. It's a single screw, so it has to go on the way it has to go on. Okay, I'm just going to grab this camera from here. I'm going to hold it over there. Take a look and see. I will hold it, the chassis is sideways. I will hold the camera the way we would see the switch. Let's take a look at this situation here. Oh, maybe the focus is... What's with the focus here? Okay, hang on a second. How did that happen? How did the focus get out of there? Sorry for this. Just bear with me a second. Focus up a little too close. Let's try that. There we are. Now we're looking at, it's on the same angle on the camera that it would be if you were looking at it. The camera sideways, radio sideways. So normally this side, this is up. This is up. Yes, it is up. It's up on the screen too. So off doesn't quite make it. Okay, that's surprising to me. I thought this... I can't put the switch on any different because of the flat spot. Well, isn't that odd? That's really odd. Okay, so up is a little off to the side here. Now we turn it. So it says in the instructions, all switch sections viewed from front and rotation clockwise. So if we rotate this clockwise, we are turning this all the way to the gramophone setting. These last two settings turn on the gramophone. So we're going to go back and look at that first switch. This will be all the way clockwise. Look all the way clockwise here. Sorry about the focus. The switch is open. So what is this switch doing that it's open while the set is all the way clockwise and set to gramophone? Because if we follow one wire, let's follow this one. We go up and up and up and up through a resistor to what is the B plus bus line here. So that's B plus coming down, snap the switch, one setting. It's not making sense to me. One setting, I would think those would join. Okay, now clockwise, viewed from the front. You see, clockwise is different depending on whether you view it. So viewed from the front, and the switch is all the way clockwise. I'm not going to get anywhere here doing this today. I can't even get past this. So a switch is all the way clockwise. So if I'm going to turn the switch, it has to go, how am I going to show this on here? It has to go this way. Now here we go. This is section A. Oh, my head is going to come apart. So on this diagram, you see where it says S2B? B refers to the side of the wafer with the switch contacts. But when you look at the switch, you tend to look at these terminals. So for instance, I gotta go over this again for my own sake. You look at this now. This is a pictorial image of the switch showing you the location of components and the like. And can you see S2C written there? And if you go down, S2D, S2A, S2B. Now you gotta look at those lines and arrows. So this is supposedly S2B. S2B. Now if we look here and we ask, well, where is it? Which side of the S2B is at the back of the switch? Okay, so hang on tight now. So we're looking now at the back of the switch. We're looking the wrong way. We're supposed to look from the front. We're looking from the back. And it says this is B. You know what? I'm going to do this differently. We're going to start over again. We're going to work on this. We are working on this. Yeah. Well, I hope, if you have a seatbelt, you should attach it at this point for sure. So we're gonna work on this switch. So first we want to find out when it says S2B, where is S2B? Let's start again. we'll use its stuff. S2B looks like that. S2B is right on the back. S2B has only 2 connections. S2B is right on the back. We come to the back, the back here. We see 1 connection, 2 connections, 3 connections. What? All kinds of connections. Because when they say S2B, they are talking about the switch contacts. And in this switch, yes, the contacts are here, but the terminals are on the other side of the wafer. Do you see there's almost no terminals? Because there's only 2. And they're way in the back there somewhere. If we look long enough, we will find them. There's one down there. That's really caused me a lot of frustration with this radio. Just figuring that out. That was quite a while ago I figured that out, and it just held up now under my examination. So I put my own labels. A. Now what the heck is this supposed to mean? If the switch is on the B side, the wires are on the A side, and it's A, B, C, D. But you have to view these from the front. So you have to think of them as if you're looking at them from the front. And that's the point where I just lose all my synapses are on fire at that point. So okay, so that's kind of just a quick look at how these switches are wired up, overall, kind of general. Good luck. So now this is fine, this switch is fine, everything is fine about it. In fact, all the wiring in here, all this stuff is all fine. All these resistors are correct. Everything's correct according to the study that I've been doing all these hours and days, and you've been watching. There's nothing out of sorts here, but maybe there is. I've made a mistake. Maybe there is something out of sorts, and it's hard to check your own work. So anyway, that's a look at one switch. Now, if we just come back a bit here, it's a little out of focus, but let's not worry about it. Each of these switch wafers has a job, and I've realized what the job is. I'm going to switch cameras now. I think maybe, well, you know what I'm going to do? No, I won't switch cameras. I'm just going to put this in the camera stand here. That's a better move. And then I'm going to refocus so we can see the whole circuit here, having taken a close look at it. Okay, what a monster. Now, but it's not as much a monster for me now because I've been figuring it out. So we now know this is, or at least believe me when I say, this switch is open on the 2 phono settings and closed on all other settings. What it's doing is it's closing on a feed, I think it's up this way, feed to all the screens on these front tubes. So by opening the screen connection, you shut all these tubes off. Now why would you want to do that? Because you've switched to phono and you don't want the radio working. So this is just a way to get it out of the picture. Just shut it off. Great. That's what that's doing. That's simple. Now, if you look at all the red lines on it, this switch's job is to select what signal is going to the grid of the first amplifier tube, to this grid here. What's it got to choose between? It's got to choose between 2 things. The radio, here's the radio audio coming out here, coming out of the detector here. It's coming out, coming down into the switch, and then stuff goes out this way. It goes out, follows this line here through the resistor, past the capacitor, and on up to the top of the volume control, which is the input end of the volume control. The output side, or the bottom side, we'll get to that. So the red is marking the radio audio signal going through here. When you operate the switch, now look at the switch, how they've shown it here. Again, this is all about me talking to me, and you're listening. So look at the switch here. yeah, if you look at all these switches, they're all kind of different. Let's see. So this one has no center ring and no no moving contact. Let's call it a moving contact. This one has a sliding ring, has a center ring with a moving contact. So you operate the switch. This thing is moving, going around. This thing is connected to the ring. This is like the ring extension being moved, and this wire is showing the connection to the ring. So you're basically switching this wire onto different things. That's how this is working. Now we come to this one. It's got two things. Now we'll have to assume they're both connected to the ring, and when you rotate it, both of them move together. And what they're really doing is they're tying, like in the position of the switch right now, which remember is in the it's in the last phono position. So there you are. So this connection's here, and this connection's here. So basically the switch is straight through, like that. Straight through from the phono input, phono unit, I don't know what, PU, through, it gets onto this wire. And follows this wire until it finds a way to get onto here. So one way is around here, up here, and out. Another way, under this particular arrangement, I don't think there is another way. Yeah, in on here. So I have a problem with this switch. Not clear to me what this is. So if these two are rotating together, then that would look to me like you're snapping a, let me get something here to show. This'll have to do. Okay, it's a little large. You're snapping something like this, you know, all the way through. Why do you need this connection? So I don't know what this is about. You would think, okay, so this is connected to the ring. The ring is always on the sliding contacts or moving contacts. But aren't these shorting through? Aren't they connected through? So maybe I have to spend more time on this switch to really understand it, but that's far enough for now. Suffice it to say, sometimes the signal is going through two capacitors, sometimes it's going through one, always going through this resistor, always facing this capacitor here, but switching these. So this is the audio selector. Audio selector, phono setting radio killer. Now what about these last two? So you see I've drawn it with blue colored, not to be confused with the blue wires in the radio. So the blue starts way up here. You have the speaker operating, and we have two wires coming off the speaker. One of them just goes to the negative bus. I guess that provides a reference, because the other wire is going to do something, and you need to do something. You need to have this ground wire here, because this wire, which is now carrying a signal relative to the negative bus now, is carrying it. It's heading back for the volume control into the bottom. So you have a direct wire connecting. This is good for me to do this because I'm just putting little subtle pieces of the puzzle that were in contact, and I didn't even realize the puzzle pieces were in contact. Now I do. This is a solid, non-stop wire to the bottom of the volume control. Or is it the bottom? So we follow the blue, we see that there's two more blue wires coming off. One blue wire goes here, one blue line. The other blue line goes here. So these two switches are fooling around with the feedback circuit. Let's look at this one first. It's got some feedback. I'm confused again because it shows it connected to the center ring with two switching contacts, but this time they've filled this contact in and they've left this one open. You see? Open, filled in. I don't know what they're trying to show with that. Are they trying to show I don't know. That's they're trying to show I don't know. That this doesn't actually do anything. I don't know. Another thing about these switches, wait, can you switch it so one of these moving contacts is on here? It looks like it, because when you look at this one, and you're going to switch, this switch is going to go, this switch has, well, how many settings? Listen. 1, that's the off. 1, 2, 3, 4, 5, 6, 7. 7? I thought it had 6. 7 plus a starting point. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12. 12. That's why I thought it was 6 positions. 7 positions. Come on. Really? Let's try that again. The off, that's 1. 1, 2, 3, 4, 5, 6, 7. Well, that is why I'm running over this. So I don't know how 7 fits into this. Oh, man. Okay. Stop thinking. Keep looking. So we have these 2 switches controlling feedback, which is heading up towards the volume control, but something interesting is happening. The feed to the volume control from this switch is here. It goes up. It connects into a tab on the volume control, which I've fiddled with mightily in the past. This is a fixed tab, doesn't slide anywhere, it just sits right there. On this diagram, the tab is showing close to the quiet end of the volume control. I think on an earlier video I got this turned around. Not that it mattered at that time, but I think I might have said you move this up to get 0 volume. No, you move it down. The interesting thing is it passes where the tap is. And in this radio, it appears to me when you push the volume control past the tap, things get really weird. But I'm not sure of that. Maybe today we can examine that question more carefully. But suffice it to say, this switch pumps feedback manipulated by an RC circuit and another capacitor down here maybe into this tap. The other feedback switch, which is getting its feedback here, is doing something crazy with it in here, but out it can go. It goes through a capacitor into the slider. So there's quite a few ways of thinking about this. If we just forget the fact that the slider moves, then we're pumping in feedback, a feedback signal into the bottom, into the side, and right into the thing's head. He's overwhelmed with feedback, much of it manipulated by capacitors. So what's with the feedback? So the feedback does 2 jobs. One job is to basically act as an error signal where distortion has occurred in the output when compared to the input. And it's kind of sounds like you got like a computer program running, but it's nothing like that. It's all hardwired, straight stuff. If you send a little bit of this back, and as a form, I believe it's negative feedback, it will introduce the opposite of the distorting factor, if I can put it that way, into this amplifier and then this one too, and it will undo the distortion by detecting the distortion out here. Now, isn't that a mind breaker in itself? What do you mean? It eliminates the distortion that it's finding here? Well, I guess it kind of locks it down and holds the circuit in a state where the chance of a harmonic distortion is greatly reduced, or any kind of distortion is greatly reduced. That's a terrible explanation of it, but it's good enough for me to get along, so I'm going to go with it. So that's one purpose. Clean up the distortion. And it has a dramatic effect. And it allows radio designers to be less concerned about distortion on the way to the speaker, because this guy is going to knock it out. The price you pay is a loss of volume. Not quite as much volume coming out of here. Something else you can do with this feedback is you can manipulate the tone of the response, tonal response. I guess in somewhat the same way, kind of like a negative feedback, but it has to be only for bass or for treble if you're going to manipulate the bass and the treble. And so I believe a lot of these capacitors, what they're really doing is shaping this feedback signal in the sense that they're changing the phase of it a little bit. So its phase relationship with the incoming signal is different, and the phase interference creates the tone control that they're trying to get, that the engineers are trying to get. That's what I think is going on here. Feedback. What does feedback do? We've all heard microphone feedback, squealing and all that kind of stuff. I mean, here it is. They actually wire the feedback right in there. Why doesn't every radio using feedback howl away? Like, now, radios use feedback. They'll take the feedback. They'll go farther back with it, or maybe there's a couple tubes here. They'll feed it into particular tubes. Engineers go crazy with this stuff. I mean, just like I'm going crazy with it, except I'm not engineering this. Thank God. And I wouldn't be surprised if a lot of experimentation lies behind all this. And when they get this thing working satisfactory, they probably put a big stamp on it, done, and don't ask any more questions about it. You know, this is back in the day where did they really have all the equipment? I don't think they had a shop as good as mine back then. So you know, I guess in the design engineering place, they probably did have one whopper of a test bench to mess around with all this stuff. And you know, it'd be great. While they're messing around, they make a discovery that no other radio manufacturer knows, like how to manipulate feedback to generate really decent tone effects, and this is their little secret here, which they probably wouldn't want to talk too much about. Although a really good engineer would probably look at this and sort it out pretty quick. And I guess that puts me on a scale. On a scale. Not on a par, on a scale. So, now, what's happening with this thing? So, it makes a lot of funny sounds. It makes two sounds. At the lowest volume setting, it makes a classic motorboating sound. At a higher volume setting, in my imagination, just as the slider, just as this slider is crossing this point, it changes to a more classic sort of sounding hum, but at you know, I don't know, 150 hertz, a bit of a high pitch, low hum at a high pitch, if that makes sense. And then the moment you seem to get a little further on, it's over. The hum is gone, motorboating's gone, and you can start hearing the radio audio. Can you hear the radio audio down here? I'm not exactly sure, because this thing's, you know, humming away and doing stuff. But maybe underneath that, the volume control is just doing what it normally does, which is bring the radio to zero. Now, there's some really weird things going on here. When you slide this past this point, there's a ground here with a resistor, R9. How much was R9? I'm just looking here. 22K, 22,000. And this is a million. It's a million now. It's a little more than a million in my radio now. The original volume control was 5 million from here to there. And I assume that something has gone wrong with it, and that's why I replaced it. Now, the effect of doing that, the action area, if I can call it that, was down here. Most of the volume control was behaving like a volume control. And I changed it from 5 meg to 1.3 meg. Now, most of the volume control is involved with the feedback. So this crossing this point thing, you know, I'm not sure that's really a factor at all. But surely to goodness something weird happens. Now, each like, you know, this wire, this wire, this wire, they all got to have exactly the same thing on them. Up until they meet up with a capacitor or something like that. Like, it doesn't look like there's much at all here on it. To snap this twice, and it would be counterclockwise. So I think this goes snap, snap. Now the feedback. Oh, you know, I never drew this line out here. I drew it out here. So this is the output side of the switch. Yeah, I didn't mention that. There's an output and input side. You can look at these switches this way. Like if we look at this one, we can say this is the input side of the switch. Look, they're all connected together, except for the last two phono. And this is the output side. Did I say that before? So we can do the same thing here. We'll assume the input is the feedback. Comes in, gets on the ring. Counterclockwise, snap, snap. Well, we're in that situation where this uncolored thing here, remember, it's hollow. You see this one's got a dark thing in it, dark thing in it, dark thing in it. Hollow. Yeah, I have looked at the switches to try to see all this stuff. No, I just could not eyeball it enough. So again, click, click. Now we've connected the feedback, if I'm interpreting this right, to this wire. Now we have feedback. So what if this means there's nothing here? Why did they even show it? Why would they even, if there's nothing there, why would they show it? What are they trying to show by filling these in? What did they write in there? Did they write something in there? Okay, wait. I'll take a super close look at it. I just have to refocus the camera here. What were you doing, Mr. Draftsman? It's an arrow. Wouldn't it be an arrow? I think those are arrows. Look, they match the other arrows. No arrow. Oops. Well then, well, and if we pretend the slider here means nothing. But it has to mean something because you've got this connection coming to the center ring, and the center ring comes out on here. This has to mean something. Does it mean that the draftsman was just inconsistent? Is this the secret to the whole thing, Jim? This is it. You don't understand this little tiny thing, you'll never understand any of it. I mean, it's clear what he's done there. Okay, so this switch is supposed to be in the most clockwise wait one cotton picking second. All switches shown in fully anti-clock position. All switch sections viewed from front and rotation clockwise. Like what rotation clockwise? Well, yeah, that would make sense. It's in the anti-clockwise position. The only way you can rotate it is clockwise. Hey, I got that figured out. That's because in grade 2 we had this great big clock. Do you remember that? When you were in grade 2 being taught how to read a clock? I think it took 6 months and lessons every day. Read a clock. Then later in life you had to learn how to work a computer all on your own. But the clock? Hours of training. Hours. Sometimes I think about what I was taught in public school and how ridiculously tiny the amount of information really was compared to what I've picked up just in life on my own, like everybody, because the world is just a flood with information. Okay, back to what I'm doing here. I just zeroed my brain right out. Totally lost track of everything. We're trying to figure out what is going on. See, I thought I had this all figured out. What if it means don't pay attention to this? What if that's all that means? You just didn't color it in, so just don't pay attention to it. Pretend it's not there. Can't see it, so I can't see it. We have to decide what to do with it. Now wait a minute. This. Okay, so we look at this switch. The feedback's coming down here, permanently connected to the center ring. We snap the switch 7 times. 1, 2, 3, 4, 5, 6, 7. Then it's here. Wait a minute. 1. 7 positions. 1, 2, 3, 4, 5, 6, 7. In a lot of those positions, this piece is going to be contacting all these things. This is the input. Wait a minute. This is the output. The input is connected to the output all the time. These are just... Well, how can that be? Because that means, like this capacitor here, well, I guess there'd be some settings where there's no alternative path. Yeah, like where it is right now. There's no alternative path. Yes, there is. What are you talking about? You have the input coming here on the ring, through the switch, out here, and away she goes. And this path is either parallel to it and having some effect, or it's immaterial because this one is so wonderful. In fact, most of the settings you go on this way. This is, I think, R20, was it 22? R20. 33. Right, 33K, you can't say too much about it because you don't know the impedance of the circuit it's in. And 33 is kind of in the middle of the road for a resistor. Well, I've gone from thinking I understood this really well to, oh my gosh, I'm still not really picking up on how this is all working. Yeah, I have another version of this radio with a similar schematic. Does it have a similar switch? Because there's a real opportunity here to add to the confusion, and I don't want to miss out where to go. I moved it. It was in here, and I thought I got to move this away before you know it. I'm going to grab it. Here it is. Okay. So this is a very similar radio. Where's the switch? Oh, here's the switches. Here they are. Look at, oh. Okay, man, I can make it work a little better if I just do this. Here we go. Well, now you know exactly what I'm doing. So, look at that. It's the same system. Oh. Well, maybe not. Maybe it is exactly the same thing. It's just drawn differently. And if I analyze this in combination with the other one, other than the blood coming out of my ears, it should work out pretty good. Look how they're showing, oh, I have to study this for hours to figure out how they're showing this switch. It doesn't look anything like the other one. So that's the moving ring. That's easy to understand, and that's almost certainly what I thought this switch was doing there. Yeah, see, I think it's getting onto the screen line. Screens, yeah. Yeah, so screen switch to turn the radio off when the phone was on. Don't know, but it's only doing something similar, I guess. This is... Heck, we'll look at the volume control in a minute. I have to get some cotton bat and put in my ears first. Resistors all around this. They've drawn the resistors all around this thing. Not like these. Well, there's a resistor there. Okay, and then this one. Well, let's just follow the feedback wire on this radio. So let's come up here. There it is. Very similar. Coming back, going down, going over. Okay, so it's making its way into this switch, but it's making its way up here. Where the wires cross, they don't connect. It looks kind of similar to the other one. Oh, goes to the negative bus. That's different. How did I get over here? I thought it was over here. Let's look at the volume control now. The volume control has a tap on the back with just a capacitor, no resistor. The volume control has a single blocking capacitor. The one I have has two of them because they block it on the leading wires. They're just blocking it right on the main slider wire. Go up to the grid, down in two directions, down through a resistor. So R17 is going to be a big guy, I imagine. R17. Where are you there? 10 megohms. That's a big guy. That's a really big guy. R17, but look, down and around through another capacitor into the switch. So you got the feedback into the back of the volume control, but none going into here, into the tab. Instead, they have this switch. Where'd it go? This one. Was it this one? Wasn't one of them outputting onto the negative bus? Well, this one has a resistor to the negative bus, but it also has this. Well, it's also to the negative bus. What about this last wire? C27. Oh, son of a gun! Up it goes. Back of the volume control. Wait a minute. Where did this one go? Top of the volume control. Wait a minute. Can't be the top unless it's carrying the output from the radio. Let's follow that. So we'll find the output from the radio. Where are you? Where's the rectifier? Here it is. It's just hard to see, little tiny plates there. Look, it's done differently. This one's done differently. The two are connected together in a single, acting as a single diode plate. So the rectified or detected audio is here along with the AVC voltage, and this is done differently. It's just been done differently. Coming down though, through here, along that wire. It's going down. It's going down into here. It's only on two contacts. Two contacts, but see the slider thing is wide. And so it comes in here now. So there's a record player input right there. So the output must be this upper part. So the output coming out, it's going up top of the volume control. How do they get to the top of the volume control? Two different ways. I must have done something wrong. So anyway, there you are. Audio switching radio and phono stuck to the top of the volume control. Back of the volume control, no. You know, they had so much trouble with the feedback system on that earlier model, they did away with it and made this. Well, now I've cut the wires off on this radio previously from this tab, completely cut them off. and it still made the sound. But now that's quite a piece of information, Jim. I've got too many pieces of information. I can't weigh them relative to each other. Oh my, so no bright light has turned on here while I've been doing this. I was hoping that would happen. I think what we should do is operate the radio in all the different selector positions and just consider what's happening. And maybe we'll find one setting that is particularly interesting on the tone control, and maybe that will lead somewhere. Yeah, I often wonder, how much of these radios was built by an engineer sitting at a desk with a pencil and a slide rule making calculations and drawing diagrams, and how much of it was developed in a laboratory with a couple engineers and a box full of parts going, I don't know, let's try the .01 here, and doing that kind of stuff. And it's probably a combination of the two things. And how much you want to bet they didn't build prototypes of radios and end up with exactly the kind of problem I've got here that they're trying to sort out in their prototype. Those poor engineers. I think that's why once they got one of these things to work, man, stop developing it and build it. Don't fiddle with it. And build it exactly the way it's supposed to be built. Now I'm standing here staring at the wrong schematic, you see? Let's put that away. That was interesting. Let's do the next thing. Operate the radio, listen to its operation, think hard about these switches, and look forward to going outside soon. Yeah, but temperatures changed here. Yesterday it was 31 degrees. Not terribly humid, but 31 degrees. Today I think the high is going to be 18 or something, going down to close to freezing. The weatherman said there's a chance of snow tomorrow morning, but I'm sure it wouldn't stay at all. But okay, I'm going to turn the radio on while I'm yapping here. Okay, all set. There we go. How much you want to bet it doesn't do its tricks when it's running on low voltage. Oh, that does one of them. Oh, won't even stop. Am I adjusting the bias on a tube? Give her. And let's find out what setting we're in here. Okay, so we're in the opposite, I don't even want to say it. We're in the usual setting. Okay, here we go. Usual setting, first click from off. We get that motor boating. And we get the oscillation, and just above it, you can't really hear it. The radio's working. I'm going to stick my finger on the antenna, grab your volume controls. So the volume control is doing the volume thing fine. It's just this motor boating problem comes on top of it. Get rid of the motor boating, radio sounds great. Yeah. That's the first setting. For the second setting, we're hoping for something dramatically different. That really sounds like a motorcycle a friend of mine had, his brother had rather. Really old one. Oh, okay, so it's a little different there. There's a helicopter flying over now. And the radio's working there. Next setting. Same motor boating. Well, won't stop. Next setting, this is the last tone setting, I believe, for the radio. That's what your Indian motorcycle sounds like when you get it all fixed up. Well, the next setting, I think, is the first phono. I will check. Yes. Phono. That's where we were. Phono. There's a dramatic difference between the phono setting and the radio setting in that the input is coming no longer from the radio at all. It's coming from phono, and there's no phono. There's no input. So that's a dramatic change, and yet it doesn't change the effect much. Okay, and then one more. Phono. That affected it. Yeah. No oscillation there. Come on. No. Did I go the wrong way? No. Right at the end here. Where's the click? Showing up. So that's I'm sure that's it. I'm not sure. I suspect that's a capacitor discharging each time we snap into it. Snap into it, Jim. Phono, radio. Difference on the phono. Okay, big difference on the phono. What is the difference that's affecting this radio on the phono setting? What is changing so much? Okay, so this is the input guy here, and when we're on phono, we have just feed coming from the phono cartridge to here, meeting up with the arrowed diamonds. It has to go on the center ring here. I mean, if it doesn't, it's going nowhere. So it has to go on the center ring. Wait a minute. Wait. This is set. Where's this set? This is, here we go again. All switches in fully anti-clockwise position. I'm in the other position. I am in the other. Oh yeah, I see. Yeah, right. Okay. Just sorry, thinking the same things through again. My brain is doubling over old territory by accident. It's a sign I've been in here a little too long already. Okay. I just lost my place here completely. Right. So we're wondering why changing to phono input has such a dramatic change. So there's nothing out here, but we're not on phono and we're on a radio. We're on these four down here. It must be that as you rotate this double diamond switch, it's a through switch. So you're connecting the opposite terminals. But look, there is no opposite terminal right there. So when you snap this thing twice, click, click, when you get over to the non-terminal, the only way for the signal to get out, which is coming from the radio now, is to leave on the ring wire. Whereas in other settings, you snap it one more snap, now the ring through this diamond is connected to there. It's got a way out, not on the ring wire. It's got to be what they're doing. So when you turn the switch so the contact is there, you are actually introducing this extra guy, extra capacitor. In my mind, that's pushing the phasing of the feedback a little bit, but I don't know that for sure. And then we have this feedback that goes up into here, the fixed. Well, I haven't. I thought that. Anyway, I thought they drew a. I don't know. Who knows? I think that's a dot. It's a dot that looks like an arrow. Never mind. So what's going on is because I don't know what to think about, my brain is just thinking about stupid stuff that comes up in front of it now. Because I'm overloaded. I should probably take a break and drink a little coffee, go say hi to my cats, and come back at this in a few minutes. Once I've sort of, cleared off my desktop, so to speak. Yeah, I'm doing nothing here. Doing nothing. Overloaded. Time for a break. Break time. Break time. Oh my gosh, I've been at this for an hour. Maybe it's a longer break. Maybe that's it for today. Oh my gosh, I've been at this for an hour. Okay, I don't know what to do with this. Should I post this? Maybe I'll post this. If I posted it, I apologize. If you watched that, I don't know if that's entertaining or not. So, anyway, thank you very much. Yeah, I'm going to stop now. If I pick it up later, I'll just pick it up on my own during the day, here and there. Probably not. Going to be out doing gardening. Hey, that sounds good at this point. Thanks a lot for watching. And see what happens.